Okay, today we are going to do this topic, volume of revolution or rotation. So you see this is the y-axis, this is the x-axis, okay? So you look at this point, okay? When the x-axis rotate, that means this point will rotate in the circle, isn't it? It will rotate in a circle with the center here. The x-axis is the center. Okay, so if you see it from here, you will see that this is the x-axis, then this point will rotate like this in a circle like that, 360 degree or 2 pi radian. Okay, so if you see from here, you will see something like that. This point will rotate, this point, the point A, it will go round like that, it will go round like that, the circle. So same thing, when the y-axis rotate 360 degree or 2 pi radian, then you will see that this point, now you will see from the top, you see from the top here, you will see that y-axis is the point like this, then the A will rotate like that, down the y-axis in a circle like that. Okay, so it will rotate like this. Okay, so you see now. Let's say I have a straight line like this. This is y-axis, x-axis, this straight line. So straight line must have many points. Straight line is made up of billions of these points. And this point, how big is this point? It's one electron. So you see, every electron here will rotate like this. Every one will rotate like this. So it will rotate. So when you combine together, it will become a cylinder like that. So it will rotate like this. Okay, it's a round. So you will see from here, it is a cylinder. Okay, it is a cylinder like that. I lie down. Okay, it's a cylinder like that. It's a cylinder. Okay, and then how to find the volume of a cylinder? Therefore, it's pi r square h. The r is 2, and then the h is 3. Okay, so there's the answer. Okay, now you look at the next one. This is very simple because we have the formula to find the volume. Okay, now if let's say I have this point, then this line is made up of many points like that. Again, these are the size of one electron, so every one will rotate like that. Every one will rotate when the x-axis rotates, so everyone will rotate in a circle like that. But we have big circle, we have small circle like that. Whereas here all the circles are same size, but here we have big one and the small one, and this point, the last point here, it will fix here, it won't rotate, okay, because it touches the axis. So this one, when it rotates, it becomes a cone. So what is the volume of the solid form? From the solid, we call it a cone. Then this is 1/3 pi r square h and so on. So you get this. Okay, so I think this one no problem. You have learned in your lower form. So today we are going to do this. Okay, volume of revolution about x-axis. Now this is not the straight line. This is a curve. Okay, so what happened is this curve is made up of many electrons like that. Many electrons. So when the x-axis rotates 360 degrees, all these electrons will rotate. It will rotate, and then you see that they are of different size. The circle from small one to big one, big circle, with the center here. This is the center of rotation. Okay, the center. Okay, so therefore now we want to find what is the volume of this solid. We don't have a formula because this is not a cylinder, this is not a cone. So what is the formula? This is what we are going to learn here. Afterward, I shall show you. I just show you when this one is the x-axis rotate. So you see this line, when x-axis rotate, you get the shape, the solid, something like this. This is something like the hat, topi, 帽子. Okay, and then this one, the same line, you see the same line, then this one, the same line, exactly the same line. But when the y-axis rotate, then you see all these points, now they will rotate in this direction, isn't it? So you get something like a bowl. So what am I trying to tell you is, when rotate about the x-axis and rotate about the y-axis, the shape, you get a different solid. That's why the volume will be different. So later you see that our question will tell you which axis rotate, whether it's x-axis or y-axis, because different axis rotate, you get different object, even though the line is the same line, the curve is the same curve, but the shape is different, so definitely the volume will be different. So here, volume of the solid form, of the solid revolution form, what is the volume? This is what we are going to do. Okay, so what I want to tell you, when you read the question, be careful whether it's x-axis or y-axis rotate. Of course, our question all will rotate 360 degrees or 2 pi radian. Okay, that means it's in one complete round. Okay, so here I just tell you I add something here. But let's say I have a curve like this. Let's say I have a curve like this. So you see, all these are electrons. All these are electrons. They make out all the point here. So here, if you want to get one complete circle, you need only to rotate 180 degrees. Why? You don't need, that means pi only. Why? Because we have two parts. Because this one and this electron, you see, when this electron A rotate, it come here. So when this one come here, this electron A1 already come here. That means two of them will make up a one complete circle. That means A1 will move along here, this A will move along here. So they will make a complete circle. So they don't need to rotate 360 degrees. So they need to rotate only 180 or pi, because this A will rotate follow here, and this A prime will rotate follow here, isn't it? So they just rotate, just like we have the field, the running track. So we have two person running. So if they want to complete the circle, this one have to run only 180 degrees, this one also run 180 degrees. So they will complete the circle. But for this one is different. Let's say this one. Let's say like this. This one, if this part only is different. For this point, you have to run 360 degrees. This one has to go one round like this. So that means if this part only half of this part, then it must be 360 degrees to make a complete round. Okay, then only 360, then only complete. But this one don't need, because this one A will run here, whereas A prime will run here. Okay, so that is why sometimes you will see 180, but sometimes you will see 360, but mostly will be 360 your question. Okay, so just because of this. Okay, so but of course all are complete round. Actually it won't affect our formula. Okay, so now I'm going to show you how to get the formula now. Okay, first we come to this. Okay, now we look at this. Rotate at the x-axis first. This is the x-axis. We rotate 360 degrees or 2 pi radian. So rotate. So we get, this is the curve. We get a shape something like this. Okay, so let's say this point is 1, this point is 4, this is x-axis, y-axis, and then the x-axis rotate. Okay, so you see when it rotate, I told you just now, this one made up of many electrons here, all the size of one electron. So that means very, very small, and then you get all will rotate in the circle. Okay, now you look at this one. Okay, for this one, this is, look at this one. This is actually, you look from the front, it's a circle like that. And then the radius of the circle for this one, the radius is y, isn't it? The radius is y. And then what is the thickness? What is the thickness? It's just one electron. The thickness is just one electron, the size of one electron. Therefore, the thickness is dx, which is very, very small. I don't know how many zero. It's very, very small. Okay, it's the size of one electron. So this is actually some sort of like a cylinder. Therefore, the volume of one disc like this is called a disc, very thin, and then the volume is pi r square h. That is the volume of a cylinder. Pi r square, h is dx. Pi y square, the radius is y, isn't it? The y. Okay, so the volume of the whole solid form, this one is the whole solid. The whole solid will make up of many of these billions of them, because we have billions of electrons, okay, rotating at the same time. We have billions of them. So we have billions of this from the small one to the big one. So now we have to add up all the volume. The first one, the first disk is pi. The radius is y1. Let's say the radius is y1. So y1 square dx, because one electron. Then the second one, the radius is slightly bigger. So the radius is y2 square dx. Okay, here. And then you have so many until here. This is pi y square dx. This is the general one. And then the last one will be pi yn square dx. So we have billions of them. So when you want to find the total volume, you have to add them up. So how to add them? You use integration. So you integrate. So that is the formula. So this is the formula. So when you rotate about the x-axis, this is the formula, pi y square dx. Okay? So the volume of the solid form will be pi y square dx. Okay, so you see for the area, okay, for the same question, if I want to find the area, you see when you want to find the area, the same curve, here you have, again we have many electrons here. The curve is made up of billions of electrons. Okay, you look at this electron, the height is y. Okay, so what is the area? We have learned already is pi y dx, and then from 1 to 4. So why I want to touch on this area again, because you can see the formula for area and the formula for volume is the same one, almost the same. Only here for volume you have pi and then square, isn't it? But area, no. Okay, so this is what you must know, the first one. Okay, now we look at this. Okay, now we look at this. First with the x-axis rotate, the y-axis rotate, we will do it afterwards. Okay, now we look at this one. Let's say we have, don't look at this part yet. Let's say we have these two curves. One is y1, and then this is y2, the red color. Okay, so this one make up of many electrons, billions of electrons. Okay, and then here also the y2, the red one, is made up of billions of red electrons, isn't it? Okay, now what happened when the x-axis rotate 360 degrees or 2 pi radian? What happened? All these will rotate. The blue electron will rotate, the red one also will rotate. Okay, so you will get a solid something like this. Okay, you get the solid something like this. Actually, you cannot visualize how is the solid look like. So you see, if I separate it, you will see something like this. First, it's like that. If you look at the blue one itself, you have so many electrons here. If you look at the blue color, tengok yang biru punya, the electron here. So when the x-axis rotate, all these blue electrons will rotate like this. Then it's something like a bowl, or this is just like a half of the watermelon, isn't it? Water bikai. Okay, it's just like half of the watermelon. And then when the red one rotate, you get something like this. Look at the red one, isn't it? The red color. So the electron like this. Okay, so it's just like a hat, topi. It's just like a topi, hat, 帽子. So what happened? What is the shape of this? Is actually this watermelon, the shape of this watermelon, and the head here, inside here, we just dig it out and then we remove. Then you have this. That means this one, the solid is something like this watermelon, but the inside, the middle part is empty. This is empty, so we remove. That's why minus. Okay. So therefore, you see what is the volume? Okay, from here just now we see volume of the solid form or generated. about the axis. So about the axis. So this one will be what? Pi y1 square dx minus this one, pi y2 square dx. So you combine, you get this. So this is the formula. Okay, here you see I touch on area. So when you come to area of the shaded region, we have already learned. So this is y1, the blue one is y1, the red curve is y2. So when you want to find the volume, again this, the area, again this one is only one electron, is dx. Therefore the area is y, the height is y1 minus y2, and then the thickness of the electron is dx. So the area is y1 minus y2 dx, and then from 1 to 4. So this is the formula. So here I just write this one together with the volume so that you can compare. They are actually the same. So what I mean is, if you know how to do the question for area, then you can do for volume. The only difference is we have a pi, then you have a square like this, but area we don't have. Okay, so that is the similarity between these two. Okay.